I'm Paul Curtis, solutions engineer at Red Panda. My background, I came into the Kubernetes world through big data and through Weaveworks. Christina?
Yes, I'm Christina. I am the DevRel for Red Panda, but I used to work for Red Hat, so I know a bunch of stuff on Kubernetes. And I think I want to kind of talk a little bit about how data streaming works on top of Kubernetes and how to make it more performant. And that is going to be how, this is going to be our talk. Perfect.
Okay, so I'm going to do the first half, and we're just going to talk about the Kubernetes side of it first. Assuming I can get back to where I was. Okay.
Yeah.
So ingesting data, the old way of doing this, everybody built web services. They did it with HTTP, right, because it was simple. Everybody had REST APIs, REST libraries for pretty much everything. Kafka is completely different, right? So the first thing you're going to realize is that the Kafka client, wherever it is, whether it's an application or on end user point, has to be able to speak to every broker, okay? There has to be a direct connection, right? So in the HTTP case, it's one socket out, one socket back, same connection, same IP address, which lends itself to Kubernetes world, which is perfect because it works perfectly with load balancers and standard Kubernetes networking, right? Standard service, multiple replicas, boom, done. Okay. Kafka, no, doesn't work that way. So a couple of things you have to keep in mind when we talk about Kafka. The first thing is the Kafka client has to be able to either resolve the name or the IP address of all of the brokers it's going to talk to, right? So in the Kafka universe, it's called the advertised address. You can have multiples of them. Right, very simple, straightforward. Kubernetes, you got a big problem right off the bat because you actually have two addresses, perhaps three, for every pod. But you have the cluster IP internally for the pod. You have the service IP internally, the cluster IP for the service, right, that's attached to that pod. And then potentially you could have either node port or load balancer as a third, right? So which one it talks to and which one you advertise is kind of critical, right? So looking in from the outside, you realize that on one side, it's very simple to find a single address. You could do a load balancer, but the client won't work that way. It just doesn't. So what you end up having is either load balancer IPs or using the internal IPs from the client library. Now, all Kafka implementations, including Red Panda, allow you to have multiple sets of these addresses. So you can have an internal one, like the cluster IPs, which is 192.168, 101.123. You can have a second set that are the external IPs. I'm giving you this because to get a general idea of how you get throughput through these things. So Red Panda's architecture in Kubernetes, very straightforward. In most implementations, a single Kafka broker or a single Red Panda broker is assigned to a single Kubernetes node for performance reasons. And there's a number of different ways to do it. That is not a requirement, but that's the typical pattern we see. Storage is there. It's implemented as persistent volumes and PVCs, so it makes it very easy to do and Kubernetes-like. And then two services. The brokers themselves are stateful sets, right? Which means that they have an ordinal number, which means you create one service for them, right? And what that service is you get a headless service. We then also create one service per broker. So there's actually four. Does that make sense? Architecture is pretty straightforward. Why do you need the headless service? We'll talk about that in a second when we talk about how the protocol works, but it makes it simpler. It also gives a naming convention that's consistent across all the services, right? Stateful set services, everybody familiar with them? Please raise your hand. You understand how they work. They're done with ordinal numbers. So if you have a replica size of 3, you get service 1, service 2, service 3, or 0, 1, and 2. Okay. That makes setting this up very simple. Now, those addresses that we talked about, the advertised addresses, which one of these addresses is the advertised address? Okay. The answer is it is the actual stateful set service, right? The cluster IP of each node, each pod, is one address you can use, and the external service IP is the other one you can use. How many are most of you deployed in cloud, like AWS or GCP? Yes? No? Anybody not that way? Anybody internal? Okay, on-prem. All right, so in the cloud, that's pretty easy. You know how an external load balancer works. Okay, so the first way to do this, and this, you'll see at the very end why we even bring this up. Node port makes it simple for on-premise, right? If I have one broker per Kubernetes node, the advertised address is going to be the IP address of that node port. In the configuration, you can set the port it actually connects to, right? Dead simple. If your networking allows it, and if your network operations people allow that. There are a lot of places where node ports are not allowed on Kubernetes clusters for whatever mysterious, legendary reason, but they do exist. In the clouds, these are going to be the IP addresses of the virtual machines that make up the Kubernetes nodes. AWS, you can get them real easy. GCP, you can get them real easy. Azure, it's a two-step process. But fundamentally, that's going to be the advertised address. Questions? Make sense? Over on here on the left, Red Panda, as a Kafka broker, you're going to see two sets of addresses. This one, right here, Kafka default, and we don't have an internal here. Interesting. They didn't list it.
Yeah, I think it's on the...
Right? So this port, that's the node port that'll be shown externally. That's the port, the container port. And the rest of it makes sense. So the advertised address will be the IP address of the machine and that port. We haven't gotten to the throughput part yet. So external address from some client, either on the VPC, internal to your network, is going to use that. Clear? I'm looking for nods. Nods. You still awake? I know, the first one after lunch is always the hardest. All right, the second way you can do this is DNS. So the Kafka client libraries will resolve a DNS address. Now, they don't really care what that DNS address is. The only thing that has to be true is what you configure as the advertised address and the DNS name have to be the same. Okay? Also, if you're using SSL, which pretty much everybody should be, that's also going to be the common name of the cert. They have to match or Kafka will not work. The clients will it will refuse the connection. Okay? So in our cases, in Kubernetes, right, AWS, GCP, GKE, Azure, they all assign you domain names on external IP addresses. You can just use those out of the box, right, for the node port. Pretty straightforward. If you're using internal, all three cloud services have internal IP addresses as well. If you're on-premise, you're going to have to pick up the DNS side of this. Now, whatever resolver you use for your Kubernetes DNS, I'm sure you have some internal domain name, right? Right. Stick it in there somewhere. All right. The pods, the actual brokers, are given stateful set names. So Red Panda-0, Red Panda-1, Red Panda-2. The convention in our world is to make the DNS redpanda-0 dot something dot your domain, 1 and 2. You can also do this, and so far so good. All right. You can also do this with a standard Kubernetes load balancer. Advantage, I don't know, is there one? I mean, I'm being honest. In the cloud, it's actually not a bad way to do this because I can turn off the external address with an annotation. I can do a bunch of things. In the on-prem world, this is by far the easiest way to do this because the DHCP address of that load balancer you control. No? You're shaking your head no. Most places that's a yes. So you're going to have another problem because you're going to end up with IP addresses and host names. You need to match those up. No?
No, we got that solved.
I'm sorry?
We got that solved, so we use external IPs with external DNS.
Okay.
Customers are able to resolve that entry point.
All right, so are you using external DNS or a tool like that from your Kubernetes cluster out?
External DNS.
Okay. That's a most common way we see customers who are using Kubernetes load balancing with Kafka clusters and Redpanda. Because that name has to match and those IP addresses have to match, it's easier to use the domain name and let tools like DHCP plus Kubernetes external DNS manage that. Also, for HA, means I can punt the pod, it'll come back and it will still work. Right? Try and node ports, you don't have that control. And that's one of the reasons people like load balancers. So the same thing applies here as it does for a node port. You need to have matching address in the DNS, matches the IP address, which matches the common name on the cert. Okay. This is the slide we're waiting to see. Why do you pick one over the other? This was a test, and I'll give you the tools to do this. This was AWS, EKS, 3-node cluster. You didn't put all the little notes at the bottom, but I think this was like M5, 2x larges, Kubernetes nodes, 3 nodes. Just standard off-the-shelf EKS. So what did I do? I took a pod, and I ran a tool called SOCPerf, which we'll give you the notes for, and if you come up and ask me after this, I would be more than happy to show you where all this is. SOCPerf was designed by Mellanox. It's designed for network testing, only network testing, not routing, not anything. All it's doing is sending packets back and forth. I put that into a pod on this EKS cluster, and right in the same VPC, on a VM separate, I put the SOCPerf client. I ran it for an hour because I wanted to get all the lumps out of their networking. What you find out very quickly is that load balancer is actually faster in many cases. But load balancer is faster for most of the time. And all of a sudden, when you get to 3 nines, it begins to turn. Right? So what are the numbers on the thing that say tail latency? That's 5 nines, 4 nines, 3 nines, 2 nines, etc. So that is what the worst performance was in any given thing. What did we measure? Latency. Why do you measure latency and not throughput? Latency you use to measure because you want to know how many hops your packet's going through and how much your traffic is getting lost in things that are not directly related to the broker. In the Kafka world, for those who have done this, this is a very specific measurement that Kafka uses for send the packet, receive the ACK. Now, node port performs the best overall. Kind of obvious, figured that one out. Load balancer performs next best, and load balancer, because there's no proxy in there, right? Because the service is on the same, the load balancer IP address and service are on the same Kubernetes node as the pod, right? That's why that works as well. Then I went over and I installed off-the-shelf Istio. Now, Istio is adding a proxy. So right off the bat, I lose a whole lot of latency right up front because there's now 2 hops. The second thing is that you notice that it goes up pretty linear, but it goes up fairly significantly when you get to 5 nines. The third thing that's not on this chart is throughput, right? When you're doing gigabytes per second or hundreds of megabytes per second, right, you have to keep in mind 2 things. If you put it through any kind of proxy, and that's all of them. I didn't pick on Istio because Istio is good. I picked on Istio because it uses Envoy. Right? Any of those proxies, sidecar proxied service meshes, are going to look very much the same. They have to be able to handle not only the throughput going through the Envoy proxy, but they also have to handle the amount of data. Because remember, it comes in on one interface, gets copied to the other one, and gets sent out. That's where that latency comes from. Any questions make sense? Yes, real quick.
Any idea what the difference between node port and load balancer comes from? What's the additional latency from node port?
Not sure. And I have a feeling it's the way AWS is implementing load balancing. Node port is the actual VM. My personal, and this is, okay, WAG. You all know what that means? My personal guess. I think the load balancer is being done in the switch. It's being done as SDN. And that's why it's different. You would expect in hardware, if you did this on premise, that those numbers are going to track almost exactly the same. Right? That one threw me off. I looked at that and I didn't expect that. I would say overall that the choice between load balancer and node port's a toss-up in the cloud. It won't be in, it'll probably be that way on self-hosted. Any service mesh is going to add to it. Okay, and now we give you Christina, and I took more time than I should have.
No worries. So I think we look at how Kubernetes works with the networks and everything. So you kind of have to decide like what kind of node port between node port load balancers and SDO if you ever want to. But I mean, for me, looking at the performance is not just the network itself. There's a lot of tunings like inside a broker, a Kafka broker, Redpanda broker, whatever that you're working with. It's mostly like that. So there's like 3 different knobs you can turn, and it all depends on your use case. If you want to go for high throughput or low latencies, these are the things that you can tune. And I want to go over some of the things that you can tune on top of it. So I mean, there's 3 different things, right? You can tune the broker itself, you can tune the producers, and you can tune the consumers. So in the Kafka world, it's a very dumb broker and smart clients. So most of the knobs you have to turn is mostly on the consumer and the producer side. It's not the actual broker itself. But things you can set with brokers, I think this is nothing to do with Kubernetes, but in terms of storage and CPU IOs, these are the things that you can actually tune to go faster. Like the disk IOs, the storage, you want to use like NVMe disk so you can get things right there faster and all that. That's like thing. But other things you can kind of work with is just bring up a number of brokers, right? Like Kubernetes is really easy to add another broker. It's very simple like that. You can, having less replications. How in Kafka world where you have to do replication to make sure your data's replicated, so it's reliable and all that kind of stuff. And then the number of partitions. So I want to look at partitions because partition is that mechanism that allows parallel processing for Kafka, right? So most of the time you would have producers writing into brokers. And I've seen so many customers. So this talk is kind of my feedback on, I work with a bunch of customers with Kafka, and this is the things that they made, the decisions they made that could have changed the world and how it applies, right? So I see a lot of people under provisions and over provision their partitions. They over provision because they think the more parallelism they can do, the faster it can go, right? So, but there's other things you have to think about when you want to do partitions, right? So for producer, when it writes down to different partitions, there's many different ways you can have your producers putting it to round robin to make it more evenly distributed, hashing keys, or you can make your own. The reason why, and then the more partition you have, the more parallel you can send it to consumers, and the number of consumer groups also kind of depend on it as well. So one of the things that determines how things run is idempotencies. If you want to keep the ordering of your message, you want to make sure everything runs through in the same partition. That also sometimes kills the performance because you can only have a single partition to kind of serve that. So that's going to slow things down. So you might want to think about how you do your customer partition on your producer side. Depends on what you need, right? So like this morning we talked about like financial users. They would probably think about different portfolios. They would have the thing in the same the same partition for the same portfolios that they get the ordering all right, but they also distribute things for the consumer groups. But if you have too many partitions, there's an overhead that has to do, right? Basically, it's like writing files. So if you're putting data into Kafka's or Redpanda, you're actually having a bunch of like files open underneath the hood, so it's going to slow things down. And then also the metadata. I don't know if you know that, but like every single time when the consumer groups consumes data, it needs to know where everything is, where all the partition locates, right? So these are all kept in the metadata. And the larger your partition is, the larger the metadata is. And that's going to, that is going to kill some performance here and there, right? So, and then also, this is just telling you like how much of the growth that metadata can become. And then, also the consumer rebalancing, right? As long as you pull off one consumer groups, and that is going to be like stop the world, depending on like what your configuration is. It's going to stop everybody, and then come back to it. So you got your consumer lags, right? So these are the things you want to think about. And also one thing about networking that I want to talk about is that people underestimate how much data they have to go through the networks. So things like they often think about how many data was sent through the networks and how many data were like being consumed by consumer groups. But you have to think about the network internally as well, because Kafka world you have to do replications. So you also need to add the factors in there. So the more number of replications you have, the more data it's going to be transferred. And also the number of consumer groups that's consuming from your topics is going to add on top of that. So this is just kind of a quick calculations of how you can determine your bandwidth and for your networks and stuff like that. Right? And here are a couple of things that you can tune from the consumer the producer side. Well, first of all, you have to think about the X. So this is something that you can kind of put into to producer is different times. So what happens if when you write data into Kafka, what happens is that it's going to store everything into a page cache, and then it gets stored into the disk. Well, for Redpanda, it's a little bit different. We write everything into fsync, so it's more reliable. But for most of the time, it just writes to that. And then it will, depending on your act, so this is like act 1, act -1 and 1, and then 0. So depending on like your configuration, this one kind of just waits for every replication to go to the other brokers and then comes back to the producer. The producer gets the act and then goes on to send another batch. This one just wait for the actual ones to write into the local disk, and then it writes to back. This one just doesn't wait, right? But there's something that you can turn on. I think this only happens in Redpanda. I'm not sure if Kafka can do that, but we write everything into memory instead of waiting that to do the fsync. And then when there's accumulated enough inside the memory, then we write it to disk. So this one can kind of have, we kind of measured it. I think we get to like 8 times faster compared to what the normally what you wait for fsync. So that's that. And then also looking at tuning the producer is that in Kafka world, like when you send data over the network, it also runs in batch. So there's the batch. So what happens is that it's going to wait for certain packets when it's full, and it's going to send it over to your broker. So things you can probably change here is the batch size and linger just making sure that you can wait longer to send it over, so less data going over the network, and you got higher throughput. But if you want lower latencies, you might not want it to move it lower. And then for the consumer side, similar story. Every consumer groups will try to fetch everything. It will wait for certain times. It's going to limit the number of data it consumes, it pulls from the broker. So the smaller, the more frequent that you pull from the broker, you're going to get lower latencies. But obviously, you're going to get a lot of traffic in your network. It's going to have impact on your throughput. So when you think about turning the knobs for your distributed data system, you want to think about how do you configure all that. So these are just some of the points I write down when I talk to customer, right? So always, there's no one-size-fits-all questions. You always want to think about the knobs you can turn, think about the producer, think about your consumers, and experiment with it. I would always start with the AC, and then the consumer is the next one I would tune. I think the consumer groups actually makes the most of the difference when I do my tuning. So I would always go there first, and then I'll take a look at the producer, and then I'll take the broker. That's my approach. Most of the time it works with our customers, right? So these are just some of the things to take out, but I think we're about time. So it's okay. I'm to the last one. So there are a couple. So all the things I talked about is in our website. It's all totally free. So you can go out there. It's all there's hands-on course on top of it. You're welcome to take a look at it. But yeah, so that's all. We're open for questions.
So questions? They turned me off. See?
Oh, okay.
Yeah.
Any other important performance tuning on the infrastructure side, other than network, which you covered?
PVs. What your PVs are going to be.
Yeah, I think it's mostly to the.
So if you go back to the picture. So in the cloud vendors, right, we've done this with all three of them. Different instance types will have local attach SSD. I highly recommend it. Just don't go anywhere if you're doing any kind of high throughput without having local attached. All right. In AWS, go Gravitons, and Graviton 3s actually are the best out of them.
XFS for the file system. You want
Yeah.
to have the
So
sparse.
if you're doing Kubernetes, right, and you're picking those instance types, we also, we tend to do this automatically. If you're doing this on premise, you would use the same technique. Basically, split up the disks, use LVM, and stripe it. Okay? We do that with the LVM CSI. So there is an LVM CSI that will allow you to do it. It will allow you to pick the file system type. Pick XFS for that. This is directory traversing, and there's a bunch of little tweaky things that make it go faster. That's the key. If you can get because what is message streaming? I/O from network to I/O to disk. And so we're optimizing for that. The last thing on Kubernetes for infrastructure, Red Panda, unlike the Java-based Kafkas, I can do CPU pinning. So you want to use guaranteed QoS in 2.6 or later, and 2.9 they're actually going to have real pinning, right? Definitely want to do that because the way Red Panda works is it does a CPU set as one of the first things it does. So if you give it 8 cores, it's going to use 8 cores. And it will eat 8 cores very quickly if you're doing high throughput.
And if you're doing that, you also want to make sure you allocate enough memory for each CPU core as well, because it will allocate that particular, and that threads will keep writing into the memory and then push everything in the chunks. So you want to make sure you have enough memory to.
Yeah, we have, if you go to the docs, there's a set of rules of thumb on that about core to memory ratio, just in general. It's not anywhere near as bad as Java. Okay. Any other questions? Yes.
I know I don't think we talked about it, and the proxy, right?
Mm-hmm.
Any suggestions, guidelines? On that?
Okay, so yeah, there's a whole nother set of services. So remember we had the headless service? All right. One of the reasons that's there is Red Panda's brokers. We got that picture?
Yeah, I'm trying to find it
Yep,
here.
there it is. built into the Red Panda broker is not only a Kafka broker, but there is a schema registry and an HTTP proxy. If you use the headless service, do it as a load balancer so that it just splits across any of the 3 brokers. The proxy works on all 3. The schema registry works on all 3. So standard, multi-replica LB.
Yep.
Wow, that was a very specific Red Panda question.
All right. Any more
Nope.
questions?
Great.
Cool.
Thank you.
Thank you.